for you today is this kind of like organic modeling mouse. But what I will do is I verify that all the steps are viable and okay, and there's nothing, the methodology and all the steps are good. So I will start fresh. So as a reminder, OnShape, how to get started. You will start your document here, right? Okay, so let me start a document. So you have to say document. Okay, document is basically a whole project package folder. That's what it is. Okay, so I will call this organic product modeling. Product modeling. Okay, and then mouse, and then I'll call this like version 2 because I did one earlier, under the same name. But okay, so that's what I will call it. Okay, so I have a fresh new document with like just basically empty, space. Okay, so here it is. So reminder, right mouse click to just move around. Okay, so that's pretty easy. And for any hotkeys, just go to Alt C, search tools. So you can do a search here, and then if you, if you just type the tool name, then you get it here, because they're all like all over the place in these icons, but it's so hard to like look for something, like specific. So just do a word search on the tools. That's the recommended way of finding it. And then the other thing is the question mark here. It will give you the things like the keyboard shortcut. Okay, so this will give you all the frequently used keyboard. Things like sketches, like sketch Shift S. You use that a lot, obviously, right? Shift S, and then things like Shift E. These are the very frequently used one. Shift F, like the top 3, really, right? For modeling. And then the other things like things like Y for like hide the selected part, and then Shift Y for showing selected part. I mean, if you need to constantly make things visible and invisible, so this is one of the frequently used hotkey here. So, and other ones, just like learn them as you go. Okay, so and with this project, you're bound to use this package quite a lot, unless you're like the diehard SolidWorks user or Fusion user that does everything in those things, no matter what, which you're welcome to do. I'm not like married to any particular software in that regard. But so that's the reminder for the interface. So this one, my plan is this. If you look at these products, the typical way of modeling something like this is have series of planes throughout the form and draw these profile curves, and then create the surfaces that are the top, the sides, and then combine them, which is entirely viable way of doing it. But there are two aspects of that. One, it usually takes a decent amount of time to do that, because all those things, if you know what you want already, and if the aesthetic style of the form is sort of like CAD kind of style of shapes, then that's fine. But those two are actually pretty large assumptions. A lot of times when you're working at the concept level in the beginning of the projects, there isn't a lot of time available to do that kind of detailed modeling. So the time is always an issue. Instead of having like one whole day to do the model of the mouse, you might only have like 1 hour, which is pretty realistic kind of estimate. Sometimes half an hour to show something. So there is the reality of like, well, wait a minute, how could you show something really fast and get it done? How could you, And then the other thing is the forms, aesthetics, and style. If you use the planes of sketch planes and the curve method, you're going to be limited to what looks like it was built in CAD software. It's a very distinctive kind of a box that your content is limited to. And there is really no easy way to get around it, because it's the mathematics of what these flat planes are dictating you to create. So that's part of the reason why I'm showing you the method today, is that one, being able to do something lightning fast and really quick, and no matter what the concept is. and two, having much more freedom of what kind of aesthetics of forms and shapes and style that you can generate, and still end up with a CAD production capable geometry. Okay, so that's what I'm doing today. All right. So here it is. So the starting point is I first made this project folder basically. This is this document in OnShape document is a big project folder. It's an empty project folder now called Organic Product Modeling Mouse version 2. So now it's set up to receive content. So at this point, I'm going to switch over to Maya and do my like concept modeling in that software. Okay. So I'm going to come back to OnShape in just a second. So in Maya, let's see if you remember this software. This is as a reminder, you know, I have the full set of handouts for all the shortcut keys and all that. Like I had sent it to you previously. If you need them again, or if you can't find them, let me know. But you should have gotten them already. Okay. So view navigation is Alt left mouse button for rotate the view, and then Alt middle mouse button for tracking. Okay. And then Alt right mouse button for dolly, you know, zooming in and out. So it's Alt key plus any of the three mouse buttons are the view navigation. And then when you have an object, you press the W, E, or R for move, rotate, and scale. Okay, so those are the top, the QWERTY, Q, W, E, R, you know, the keys. Q for pick. Okay, and I will just say those things as I use these hotkeys, so it will be a reminder. So let's set up the units, you know, for this kind of concept modeling, but still be at the realistic, real one-to-one scale. Just go into Windows, Preferences, and you will choose the settings and choose the units. So even though, you know, electronics products, mouse, you know, millimeters are pretty usual, for the sake of like ease, let's stay with inches for today, okay? So inches, because it's a little more intuitive, you know. So, okay, so let's do that. At least for like US-based race person. Okay, so here, let's make sure that the grid is also consistent with the units. So under display grid option box here, you can choose, okay, so grid line every 1 unit. So every dark grid line here is 1 inch from here to here. And then subdivisions is a 4. So that means that every 1/4 inch, it's there's a, you know, less dark unit. So okay, so that looks good. So let's okay this, apply and close. So yeah, so we know that this this one dark grid is 1 inch. So that's good. So now this one, I'm just gonna start with a cube and sculpt it away. So cube, polygon primitives cube. And this one I will press the R key to make this. How big is this one? It's like a 2.5 inches or something, right? Yeah, let's do about that. I'm just gonna do like very small, like rough estimate. So yeah, 2.5. So that, and then yeah, something like that, about 4 inches. It's a very rough estimate, and I'm just gonna do some freeform modeling. And then in order to be able to sculpt, I just need a few sections of division. For width-wise, yeah, just have a couple of sections, and then depth, maybe about yeah, I think about like 4 or 5 sections. I think that's let's do 4 sections. Keep it simple for now. Okay, good. I think that's good. And then last but not least, let's try to keep this grid to be sort of like the ground plane. So that involves you know, moving this up. But in order to snap this onto the grid, I will first set the pivot point of the object so that it's along the bottom. Okay. So in order to enlarge this window, it's just a matter of pressing the space bar onto any other window that the cursor is in. Okay. So just a reminder. So let's do, in order to reset the pivot point here, you have to press the D button, D, and then you can click drag the pivot point to another place, D, And then in order to snap this to this bottom here, there are vertices available on this object. So it will be combining the D key with the V. So DV is the combination of keys. You see how that moves the pivot point with the D, but also with the V key, it snaps the pivot point to the bottom. Okay, so I successfully set the pivot point to the bottom, and then now I will move this object. So that's just the W key. Okay, I hit the W key once, and then now in order to snap this to the grid, I hold on the X key. So that will do the snapping. So that's a, and when you get used to it, this is lightning fast. You just hold on like DV, boom, and then V, like X, boom. And then, so it's a pretty quick operation. There you go. And then now I'm ready to sculpt. So now before I, do anything, I like to name this organic, mouse organic form. Let's see. I'm gonna say like V2 because that's a form. Okay. So now I like to click on this, icon here because that creates the new layer 1 and then assigns this form to that layer. And then the V is the visibility so that I can make that invisible. And I did that because later on, I might want to go back to this one and create like variations and whatnot. And basically I make a duplicate of this one with a Control D button, Control D, and then assign it to a new layer, like layer 2. Okay, so I should have 2 here. This first one, layer 1, is the original one, and layer 2 is the duplicate. Okay, so let's see. So this one here. Okay, so now if you recall, you can always turn these versions into a soft form by pressing the number 3, and which gives you this like the softer, smoother version. So 1, 3, 1, 3, right? I'm just hitting the numbers on the keyboard, 1, 3, and if you press number 2, you get both. So basically, the idea is that the faceted cage shape around this form controls the shape of the blob form inside. So using that, all you have to do is do a right mouse click and then choose any of the vertex, edge, or face, any of these, and just select any of these parameters, these components, and move them around. And it's about as simple as that. So let's go to the top view, actually. Let me hit the space bar. And here's the top view. Top view, let's see. I guess I'll treat this like the forward, portion of the mouse. Okay, so let's just do right mouse and then select these and then just move them around. Okay, so this is the direct freeform modeling, which is actually, for concept modeling, this is much more preferred and faster and better way because you're not really, after you have some references in place, I mean, you're not modeling something totally wrong, but you're looking for form and shape and aesthetics and flow and movement, all the stuff that you've been learning about in the 3D aesthetics class and things like that. And then ergonomics. So this is intuitive, nothing really mind-boggling, complex. Just kind of like just like drawing on paper, really. So what I'm doing here is that when I want to select the vertices, I would do a left mouse click to select, and then I would do a middle mouse click to move them around. Okay, so, and then you don't need to use the arrows. You can do this and then just click drag on the square and then move it all over the place, that if you want, which is fine. So yeah, you can go off of this plane. So you're not limited to any like flat planes or anything like that. Okay, so this is like almost like old style mouse, really, the Microsoft mouse, from like maybe a few years ago. So, but yeah, so let's say I have something like this, okay? And I wanted to do this asymmetrical design because, one, it's probably like more ergonomic sometimes, but also I wanted to tell the left and right side differently just for like, clarity purposes, Okay, so whatever thing I did here, I have something, okay? And then let's go to another view to, let's see, I gotta let's see. So I guess I can work in perspective window a little bit. So let's select the vertices and move them around. Okay. So let's see. Actually, is this lower in the front? Maybe it's a little lower in the front. So let's select some of these guys. You can always select also the edge and faces. Those are options too. So that's a whole edge here. So you can move, or you can also rotate. You know, press E and rotate. So you can get like gestures and angles like that way as well. Okay. So yeah. All right. So it's direct modeling. It's so maybe this guy needs to come up. And so here because at the concept stage, you don't want to limit yourself to like one curve that you drew for the profile. I mean, yeah, if you know what you want already, then yeah, sure, by all means do that. But if you don't know what you want, if you want to discover, then it's a whole different story. You want the freedom of just directly just making the shape changes, right? So yes. Oh, I think I selected one more vertex here, so let me deselect that. Maya selects through everything, so just remember that. That's so okay. So I'm just yeah. So here, you can take a lot of time or little time, but yeah, just you can be very quick and fast about it. I'm purposely kind of like talking through this and giving you reminders of like how the interface works and everything, so that's kind of like worked in as a reminder. Okay. If I would just working by myself, I would just like work as fast as possible and find something. Okay. I think that's kind of like decent enough for the time being. Yeah. And now, the other items that I will model is this. So like here, this is the actual geometry, but this is a preview of a softer version if you were to make a conversion into this geometry, right? Let me do one more thing with this. On the bottom here, like these are probably a little bit too round. Maybe I need a little more flatness in the bottom and then come up. So you can do several things with that. You can if you look at this, if you look at the geometry, there are these edges along the bottom here. You can either do something like a bevel to double up on these edges so that it holds the form better and gives you an accented edge, or you can take these edges and put a crease operation on them. Either one is okay at this point because it's at concept level. So I'll show you both. I like using creases sometimes because it's really quick and fast, and then it doesn't add more complex geometry. So here, if you have an edge here, for example, right? I just select a couple of them. If you do shift right mouse click, you have a crease tool here. And all you do is just click and drag the middle mouse button, and then it gives you a tighter curvature. Okay, something like that. Okay, so something like the mouse bottom, that's pretty reasonable here, okay? So now what I will do is then, I will actually do double click, just do edge selection, double click. And then what that gives me is, oh, I see, that's the entire set of edges on the front edge. Shift double click here, that selected these edges along the side, because it used to be a cube, right? And then shift double click here, and then shift double click here. Okay, so that way I got all the edges selected along the bottom, and I will do a shift mouse, right mouse, and then do crease tool and tighten up to make the bottom portion tighter. Okay, so this isn't really like exact number. It's not an exact science, but visual at this point. Okay, let's I think that's good enough. Leave it at that. So I got something more like a mouse with a bottom. Okay, so here it is. And at this point, what I would like to do is let's I'm gonna copy this, name the layer that way. You have to name it like at least one letter different, because if it doesn't, it complains and say I can't have the same name. Okay, so that's the name of the layer. And what I want to do is I want to make a duplicate of this. Control D, and then make a layer. Okay, so that way layer 2, right? So this is a duplicate, and this is the original here. Okay, and I can play with the duplicate without worrying about messing it up, because I always have this backup, So at this point, I will save this file. So I'm going to say I just copy that name and then say save scene as. Just so here, okay, v2. So this is the version 2. Okay, so save as. Okay. So now, what am I going to do with this one here? Well, I'm going to leave this alone for the time being. Let me sort of like, actually, this is the template button. It ghosts it so that you don't end up, you can just put it away. I think I'm going to do a level 3, okay, and then just template. So, oh, template makes it too dark, so I just do R. R is for reference. You cannot select it, but you can look at it, okay? So now, what I'm going to do is I'm going to create the surfaces that I'll be using for cutting purposes. This kind of overall volume of form will be cut up into different pieces. Like the mouse product has a different shell, like the top, the bottom, and also in this case, there's just a single slit for button for a compliant movement. But many other kinds of mouse, they have like this one here. It has the divided, separated part break lines. So this is one button that is cut here and here, right? So what I'm going to do is I'm going to produce surfaces that represent those cutting boundaries, okay? So that's, there it is. Let's go to the side view and draw a curve. So this curve drawing is under create curve tools, CV curve tool. And this is the front and this is the back. So if I just draw some curves here, I'm taking the shading out and then just so that you can see the curve, okay? So it can be straight. It doesn't have to be straight. If it's straight, it's gonna represent a flat, one side flat mold, which is less expensive. But if you really need a three-dimensional parting line for molding, then you can have a curved version, it all depends on the outermost profile silhouette of this form. But I'm kind of like roughly estimating at this point because this is at concept stage, not strictly an engineering stage just yet. And since it's pretty reasonable that this will be divisible into like two top and bottom that are moldable. So it's not a big problem for manufacturability down the line. So, and then I will do a duplicate of this curve, and then I will move this to the side. So I did Control D, and then I pressed the W to get this move tool, okay? So sometimes you can do X to snap it into a grid, and then Control D, and then W, and then with the X key. So you can have a surface here. I will put this one maybe about here, okay? And now you have the option of like having something like quite different from one curve to the other. If you want to modify the shape of this curve, you will do right mouse click and display the control vertex. And control vertices are like barely visible just because of, they made it like so subtle, Let's go into the option box. If you pick the curve and then do Control A, you can go into component display and then turn on these points so that they stay on. Okay, so here I can so I just wanted to show you that like you can change the shape of these curves as you need. Okay, so left mouse button to click and middle mouse button to move. Okay, so yeah, so now with these three curves in space, what I would like to do is I would create a loft surface. So there's one, two, three curves. And if you select them in order, 1, 2, 3, what you can do is you can go into surfaces. This is a space bar, okay, to bring up the menu and then say loft, and you have a surface here, okay. So this represents the mold parting line, okay, part break line that will separate the top to bottom. And like I said before, you have the option of like changing any of these shapes of these curved surfaces here, right? So I'm changing the position of these the points, which would give you like if you have the need, you can always change the shape of these surfaces to modify them. so that the profile is different from one section to another section and so forth. Okay. And nice thing is that like these curves, none of these curves, points, nor any of the surfaces are bound to any construction plane, which is quite liberating and freeform. You know, it gives you the freedom of like being able to move around. So that's the benefit. Okay, so this one I will say mouse P2 cutting form top to bottom. Okay, so something like that, something that is descriptive. Yeah, so this is mouse P2 version 2 cutting form top to bottom. So that's pretty. And then I will save this one into a layer. Let's see. Okay, and then the other ones that I will let's see. Oh, actually, these are the curves. So let me select these guys and then assign them to a layer because you know they're useful to have. You know, just in case you need to reproduce the curve, the surfaces later. And then I just put them away. You know, after I produce the surfaces. Okay. Um, one more, couple more surfaces that I will produce are the surfaces that define the cutting lines that that define the buttons. Okay, the switch buttons that you press. So here let's do CV curve tool, and just a matter of doing mouse clicks. Really, you know, nothing really. Okay, and very free form, and you can do right mouse click to change the shapes and anything you want. So it's just like any other graphic program like Illustrator, only that you don't have to deal with the handles, Bezier handles. It's just like the position of these curves. So kind of like nice curve and you know whatever size, shape, style that you want. Okay. And this one, what I will do is I will put one like lower down somewhere. A lot of times you want to do like over, like make it. Oh, where did that point come from? I think I accidentally moved it downwards. Okay, let me just snap that to the, yeah. I used it using the V button to snap that to the grid. And okay, oh, object mode, yeah. So I wanted to snap this to somewhere down here. Oh, wait, what happened here? Oh, it was there. Yeah, it's okay. I thought it wasn't visible for some reason. Okay, so it's still there. Good. All right, and then this one, let's see. I will do Control D and then move it up here. Okay. So as long as you know it's not like down here, you know, not you know, so as long as it clearly is, you know, sort of like engulfing the object, you'll see in just a second. So let me do select these two curves and then do a loft surface again, loft. Okay. So yeah, so there's a surface. One side is black and the other side is shaded okay because there's always the front and back side of the surfaces. So it doesn't really matter. You know, when you get into the CAD software, it'll recognize both sides. So don't mind the black appearance here. Yeah, and as an option, if you need, you can always, once again, you know, turn the points on and that's it's like change the shape of any of these. Okay, so if you have the need to do something like that, you can certainly do that. As a matter of fact, maybe I will do that. You know, I will do something like extra extra like exaggerated like you know points. You know, so like you have something like this going. It's a large area for the like mouse button. Okay, let's do that. So this isn't just an extrude, you know, it's a three-dimensional loft. You can also directly sculpt the surface itself. Okay, so this surface itself, if you do Control A, you can display the Nurbs surface display. Oh, sorry about that. I think the object display. Oh, components. Oh no, wait. I wanna turn on the Nurbs surface. No, huh? Wait. Of the surface. I want to turn on the CVs and okay, I'll be darned. It used to be right here, but yeah. anyways, yeah, because I wanted to have these control vertices and hull and all these things displayed like staying on. But here, just take my word for it. There's a control vertex here and here. Sorry that it's not so visible. So you can fully sculpt this to like whatever shape you want really by moving these around. I just wanted to like make the point that these are sculptable, like dynamic surfaces that are really you have the freedom to make adjustments here. Okay, so I just wanted to let you know that. Okay, so yeah, so here's that one surface, and this one I will call it let's see, what did I call the other one? Let's see, the other one, this one. Okay, so I'll use a consistent naming nomenclature. So I will just highlight, copy that, and then paste that into this name. And then this one, I will call it cutting form buttons. Buttons. Yeah. And since I'm gonna have another one, I will say across. Yeah. Yeah. So that's descriptive enough for me to know what that is. And then, all right. And then I will produce one more surface here. Let me assign this surface to this layer here, and then template them. Okay. So, oh, I thought I did that. Yeah, add selected objects. Okay, good. And then the last, surface that I will draw is the one that separates the left mouse button and the right mouse button. Okay. There are these two curves here, which I will assign to the curves layer and put them away. Okay. Let's deselect them afterwards. So maybe I will like display these so that you can see them. So let's go to the top view. Yeah, so okay, I'll draw a curve like something like this. Okay, so create curve tools, click, 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 and you don't need to go through all the way, as long as you go clearly through the other one. So okay, so let's go down a little bit, and then Control D to go up. Okay, so let's see, and then if you select both of these and then do the Loft command, then you will get a surface here. Okay, so it's relationship like this. Notice how I really exaggerated the size of these so that I'm over making it, because you don't want to be short. If you're short, then you're gonna have problems. That this is an ambiguity. It doesn't go through all the way. So you want to have the cutting surface going through the form for sure. Okay, so that's important for you to understand. And if you see this once, you'll understand. So and the fact that this one doesn't continue all the way throughout the body doesn't really matter, because I'll be using this one first to separate these button area from this body first, and then cutting this piece into two using this one second. Okay, so order of operation is important for you to recognize so that you can do efficient modeling and stuff like that. So at this point, I will copy this name, Control C, and then paste it into this here. And then this will be buttons left and right. Yeah. So this basically, I just want to name it so that it's very clear what this geometry is. Okay. So that's, I think I'm actually kind of like done, doing the freeform modeling. This is actually, believe it or not, this is sufficient amount of work definition to export it into CAD software. Now, in terms of forms and shape wise, but there is really one more important step before you do that. I will save this file once, and then I'll tell you. Okay, that really important step is the conversion of the geometry data. So right now you have two different kinds of geometry here. One is the polygon geometry, which is actually this, right? This blocky thing. If you press number 3, it'll give you a preview of the soft version, but it's actually this. So what I need to do is I need to convert this into a set of Nurbs surfaces. So Nurbs, in case you're not familiar, let me just give you, I guess, okay. So let me see. Let me do screen share into the browser. Nurbs is it's an acronym for non-uniform rational basis spline. Okay, Nurbs. So here, yeah, well, wiki article, of course, right? So basically, Nurbs is like it's a really fancy mathematical term. So we're saying if you have these series of this point, this point, this point, this point, and this point, this point, then the straight lines like these can be created, and based on the position of these points, these infinitely smooth curves can be created based on the position of these points in space. And it's like fancy way of saying that basically. And there's some really sophisticated math going on. You know, when you click and drag. This is not an interactive one, but there is an interactive page of this, by the way, which I can share with you in a second. Yeah, so it's this animated version. Well, yeah, I'm curious about that actually. Yeah, so there you go, right? So this is the animated version. So yeah, this demonstrates what Nurbs geometry is. So the CAD software being able to handle Nurbs geometry is basically saying, hey, if you want to do a car design or product design or like you know, like laptop computer from Apple, infinitely smooth, hey, we got the math to back it up. You know, that's what Nurbs is, you know. So packages like Maya, Alias Studio, Rhino, you know, they're Nurbs modelers, so you know they can handle that. Solidworks, yes. OnShape, yes. However, they don't let you directly sculpt your surfaces, you know, SolidWorks and OnShape, because they're engineering CAD software. You have to go through those profile curves drawn up in the sketches. So that's the pain with it. You know, direct sculpting is not really a thing. Fusion does that to a certain extent, but it's kind of like fusion's, you know, so that's the Nurbs aspect. So what I will do is then I will convert this polygon geometry into Nurbs geometry. Now, that's not really a regular thing. There's not a whole lot of software that can do that well or even at all. Maya is like a really unique that the users of Maya are like sort of like yes, main users are in the entertainment industry, the animators and whatnot, but for some reason they want Nurbs modeling capability because a lot of the Maya users came from Alias users from automotive industry, and the two company merged together. So it was kind of like built in that they needed Nurbs modeling. So they figured out a way to produce Nurbs geometry from Polygon, which is like usually it's a one-way deal. You can get Nurbs model geometry and produce polygons from them. That's like regular. Everybody does that. But the other way is like coming back from Hades. It's not really a known thing, but it is a thing with Maya. So I will show you this. And but it's not a direct route. You have to go through this something called subdivision surface geometry. So instead of one command, it's two commands, okay? And those two commands, ready? Here it is. So for the clear illustration purposes, visually, I'm going to put away these cutting surfaces. Oh, I'm sorry. I meant to put away, oh yeah. So let me assign this one, the cutting surfaces into this layer, okay? Yeah. So, oh, these curves I will also put away as well, okay? So, oh, I'm sorry. I meant to only select the curves. Yes. Okay. So I have this geometry. Well, remember, this is this, right? And then, so taking this, I will use the commands under modify, convert. So first one that I will use is a polygons to subdiv. Subdiv stands for subdivision surfaces. So that is a special kind of thing. It's a hybrid between like Polygon and Nurbs, okay? So I will do that conversion first. And then second step will be subdivision to Nurbs. So it's one after the other, you know, okay? So one and then the other, that's all, okay? So it's not really complicated. I'm just telling you that they're both underneath here. So convert polygons to subdiv, and boom, and don't worry about this, like this appearance. It's not what the geometry is. It's just a fast display thing. You know, don't, if you want, you can jack up the display level, subdivision surface display level, and increase the resolution so that you get a more detailed display. Okay, so it's not an artifact or imperfection in the geometry. Okay, so that's the subdivision surface geometry. Now the second step is to convert the subdivision to Nurbs. Now what this will do is that it will convert this form into a series of four-sided Nurbs surfaces. So shading looks really, it's like, why is it green? Well, because what was actually a one integrated whole like geometry got divided into all like separate faces, okay? And by doing that, like the shader is like came out of whack. It's like, oh wow, what happened with the world? I can't shade this anymore. So let's just display properly. Let's say assign new material, and say, all right, I'm just gonna pick an Arnold shader standard surface, and there you go. I got the shading back, so display looks okay. It's the form and the shape is the same, but this is the difference. Watch. This, if you pick a surface here and move it, it's like, oh, it gets taken apart, right? Oh, wow. Gee, can I have just one thing and not taken apart? Well, not really, because Nurbs geometry math works on the principle of four-sided patches. It's the U direction, like the grid, and V direction. It's a, two axes, like base kind of math. So no, I mean, Nurbs geometry have to have four-sided patches and describable by a series of four-sided patches. So I'm just illustrating the fact that by making the conversion, I'm doing Z to go back to it, okay? By using this use command that does the conversion from subdivision to Nurbs, it does all this hard work that you would have had to do manually, but it did an automatic calculation of going through the entire form, analyzing the flow, analyzing the whole topology, and say, hey, I could split up this form into a four-sided quad here, here, and here, and here's the end result. Combination of both four-sided quadrants, and that are like curvature perfect, okay? There are instances where the curvature is not perfect in the extreme cases, but for the most part, it will come out good. So you don't have to worry about all this curvature continuity between like boundary surface, network surface, none of that. You're at concept stage, so you're not there yet. You don't have to worry. You shouldn't need to worry about that, okay? So that's what this is. So I've got this. I'm going to name this. I wonder if my naming thing still stayed. Oh yeah, look at that. Mouse V2, cutting form. Oh, these aren't cutting forms. Oh, I misspelled cutting, but this isn't the cutting form anyway. So let's see. Let me assign this to a layer, okay? So I think I will, okay, so let's do this. I'm gonna copy the name of this, okay? And then I'm gonna go to the Nurbs geometry that I just made. And this one, I will name this mouse organic V2 form, and then I'm gonna say Nurbs, okay? So this it's been the name is the Nurbs form. Okay, good. So that's descriptive enough. So I can export this and identify that this is what it is, okay? So, and then here, I will also name the layer so that it's pretty much the same name. I just have to change one letter to be different because Maya won't let me the same name of any entity, so, okay. So I think these are the cutting forms, I believe. Yes, I misspelled this, so it's just a little pet peeve. So let me just fix the spelling error. I'm a terrible typing person when it comes to talking and typing at the same time. Okay, so yeah, let's export this out. I am ready to export this onto OnShape and do some engineering on them. Okay, so here, let me just rename the layer to be cutting forms. Okay, yeah. So that's descriptive enough for me to know. Okay, so let's save the Maya scene file. Organic form. Yeah, this is a version 002. Okay, so save as. Yes. Okay, so let's export the mouse form main form first. Notice that in the outliner, this actually, ooh, what's going on here? Mouse form, yeah. yeah, for some reason there's let's see. Okay, so yeah, okay, yeah, there's like two layers or whatever names here, but okay, I'm gonna pick it at the top layer. Okay, and then I'm going to highlight the name again so that I don't have to type it, and I'm going to export selection option, and then IGES, that is a Nurbs geometry format. IGES file, and then I want to see, I have this folder called IGES, OBJ, STL, Rhino, Solidworks, OnShape. So this is like a consolidated transfer, geometry folder that I made. And yeah, so this is descriptive enough for me to export. And then I will select all these surfaces that are cutting surfaces, okay? And I'm just gonna copy these names and then export these out. So I'm kind of like separating the main form geometry from the cutting surfaces because they're a little bit different, So they're different kind of. So here cutting forms, V2 cutting forms. There you go. Okay. So I got all these exported out, and at this point I can switch over to OnShape. So far, so good. How is the review with the Maya interface? I know it's been a while since any of you touched it because, you didn't have too many lessons on it. Maybe like 2 or 3, maybe something like that, right? So if you haven't been using it, it's probably but it should go quick. It's not really like mind-boggling complex. So I will then switch over to OnShape. So this is the OnShape window. And for importing geometry from foreign software, you have to go down here. Can you see my cursor? The bottom of the screen is okay? Yeah, so there's a plus button here. And you have to say import, okay? So it's almost hidden, but don't worry. This is where pretty much all the imports are done. And this happens to be the correct location of the folder. So here, cutting forms. So this is the main form, mouse organic V2 form Nurbs. Yes, that makes sense. And yeah, so let's open that up. And then you get a choice. So some of the choices are like import to this document, which is, yeah, so that's good. And you can also combine to a single part studio. So I'm just going to leave it on this default. And then this option is this, the up direction in different software they're different. Sometimes they are Y direction is up, like SolidWorks, and then and then Maya happens to have it that way too, right? It's a Y up for today, so you have to click this on. But OnShape by default is Z axis up, so that means that if you import objects or geometry from one software to the other, that means that your objects will be rotated 90 degrees, like facing forward like this, okay? So just be mindful of that. And if you don't like to turn this on all the time, what I could have done is that I could have aligned the up direction in Maya and chose a Z axis instead. But I didn't do that, so I I have to do this. Okay, so okay it, and then it should come in. But yeah, so yeah, there are different conventions. SolidWorks is a little bit unusual that it's a Y-axis up because usually CAD software is Z up. Okay, so like automotive, if you go to car companies, they all use Z up. So it's like, what's going on? It's not coming in. Well, that's because I actually put it in. It actually came in here. Oh, actually, I'm sorry. No, this another part file, mouse organic V2. It's in here. Look at that. Okay. Look at that. It even shows all the exterior things. I don't, to be honest, I don't know why it brings these in. These aren't really part of the Nurbs surface, but I think that it seems like these Nurbs surfaces sort of contain some information of having come from this originally from this thing. So this is actually most unusual. I haven't seen this before. Usually it just brings these surfaces in and that's it. And I believe that this is a solid object. You can verify that if you go into this this view. Okay, oh, I'm sorry, this is the view. So if you go section view and then choose the right view. Yeah, so this is a solid, it's filled in, right? So it came in as a solid because the combination of these separate surfaces formed a closed volume. Okay. Now, check this out. You know, I'm not. What I'm going to do is I'm going to. This is Part Studio 1, and I'm going to actually bring these surfaces in from this Part Studio into this one. And for that, you would use this command called derive. Derived is this button here. It's very like confusing. I'm like, they all look the same to me almost, right? So it's like, wow, how do I find that? Well, jot down the name, okay, derive, and then do a tool search. Just do a search for tools, and then just type the name in, and it shows up, okay? So that's my recommendation for refinding it. And if you just, it highlights it here so you can see where it is. You can also just click on this and it'll be the same as clicking on this, okay? So here, derive. And if you do that, it'll list all the part files that are visible. Look at this, it's listing all these like polygon faces here. I don't want any of these. I want this one here, the Nurbs surfaces, okay? So I click on that and that should be fine. It comes in. Yeah, look at that. I believe this is also solid. Okay, so let's verify. Let's do a view, section view. And yeah, so that's a solid. Good. All right, so I got this solid chunk of volume that's got good curvature. It's an integrated thing. So let's see. Let's do some shelling operations. Well, yeah, shall we? Yeah, so shell, I think I can find this one. It's this one here, shell. Okay, so if you use this command, you can say shell thickness, let's see, hollow. So that's the option. So you want to turn that on. And parts to hollow, well, parts are listed here, right? Parts are basically volume, like solid volumes. So here, okay. And then thickness, I think that's 0.1 inch might be a little bit too thick. So I put in 0.5, 0.05, okay? So let's see, I think they did it. Let's verify. Let's go into section view. Where's my cursor? Give me my cursor back, please. Okay, section view. And let's do, yeah, it hollowed it out. 0.05 thickness, okay? So that's, you know, it's a 0.05 thickness is kind of like 1.35 millimeter. Pretty reasonable thickness for a mouse, so it's realistic, okay? So this section view is on. If you want to turn off the section view, which I should, you can go here, turn section view off. So far so good. So let's bring in the cutting surfaces and cut this up into pieces. So let's go plus import and go to mouse V2 cutting forms, right? So that's the file that has all these cutting geometry, and say open. And that comes in, and that I have to choose the y-axis up. If I don't choose it, this is going to be 90 degrees misaligned. Okay. So that that downloads it, uploads it to the server, cloud, I should say. It uploads it, and I think it's finished, right? So then I can go into Drive. So here you can see that it opens up another Part Studio, and it's in there, right? Look at that, it brought them all in. So here I'm going to derive, bring those surfaces into this this Part Studio. Okay, so let's use the derive function again. It's this one, derived, and then this time I'm gonna have a list of like two Part Studio files. So let's open this up, and here we have these. Fortunately, we have like 3 different names, right? Now, notice how like the name is shortened, right? Mouse V2, mouse V2. Well, what if these icon shapes are not really like revealing what these are, right? How do you know? Well, here, let me just go back to here. I recommend going into this file here and examining and properly naming these under these list of surfaces here, okay? So that's advisable. In fact, you know what I'm going to do? I'm going to go into Maya and copy the name of it from Maya and then just paste it in here, because I don't want to invent new names, okay? So I just went into to Maya, and I'm going to do rename and then just paste that. Yeah, see? Beautiful. So it really pays to organize the work that way, because it really speeds up everything and avoids confusion and like minimizes errors and things like that. Okay, so it's really recommended that you do good naming or practices and just stay organized. I know because I'm very highly disorganized and I pay the price every time. So rename. So this is a pretty fast workflow. When you get used to it, it's very second nature. Okay, so just copy and paste. You don't. So now let's go back to the Part Studio 1 where I have this form, and if I do derived, then I should be able to specify this file. And look at this. Oh, unfortunate, I cannot enlarge this, right? Well, okay. But you know what I mean. It's oh, this one is mistyped anyway. So okay, so let's bring all these three in. Okay. In this case, I'm bringing all three, so it didn't really matter too much. But in the case where you have lists of like 50 pieces of objects, well, which one do you choose, right? So here I brought them in. So I'm gonna use these one by one to let's see. Look at that. The name came in with it. So that's good. That's really great. So let's see. I wonder if I can rename it here. Rename? Yeah, it looks like I can. Cutting? Yeah. Does that update in the other one? Let's see. I wonder. Oh no, it doesn't. Yeah. Okay. I was afraid of that. Yeah. So it's kind of like one way. It's not parametric both ways. It kind of makes sense too, because it can have like circular references, which is a bad thing. Okay, so the first thing I'm going to do is I'm going to use this large surface to cut the top from the bottom. And then I'm going to use this one here going across to cut this front portion of the top from the main top. And then lastly, I will use this third one, right? I'm not using these planes right now, so oh, I'm sorry. I wanted to invisible these construction planes, because it's really kind of like clouding clutter on the screen. So like the order of operation is this one first, and then this one, and then this one. I'm just telling you ahead of the time so that you don't get confused, okay? So if you're not using some of these right away, then you can just select it and press Y to make them invisible, okay? So that it's much more cleaner and more visible. So yeah, and this operation is, I'm just using this surface to cut into this form, that's all. And the command for that is thickening command. So if you, once again, I have hard time finding this on this menu constantly. So I will use a search, thicken, there it is, okay? And it happens to be right here. What a subtle, icon. It's so like not so visible, right? So when you do thickening, you can say, hey, what do you want to do? Well, thicken traditionally is like thickening this up and ending up with a solid piece of this surface. But instead of new or add, I'm going to remove. So that's a cutting operation, okay? So that's the difference here. So Solidworks has a like cut, thicken, but here this is thicken, remove. So, it's basically the same thing, okay? So here faces and surfaces to thicken would be this one. And merge means that, hey, I'm cutting into this form. So that's why you specify. I should have renamed this actually. But and the thickness, guess what? This is going to be something really, really thin, like 1/1000th of an inch. That's like half of the thickness of a copy paper, right? So that's like unnoticeable. So you can do that. For illustration purposes, though, I'm just gonna do something a little bit thicker just to show you, okay? So I'm gonna do something like 0.05 thickness, which is a lot more visible. And when I do this, let's see, let me make this invisible, press Y, and there it is. Okay, look at that. So a lot of these, I think when we did the injection molding product analysis and examples and whatnot, we did discuss the fact that there are some distances here in the part break lines for like shrinkage, like, feel, like avoiding purposes and things like that. I noticed that, like, look at this swing here. So I should have actually had a part break line like a little bit higher to be in the like outermost tangent area here. But I'll just move on for today's purposes, okay? So, and more the reason for like really, really like, that's using a fast sculpting method, because you can fix those really fast. All you have to do is just go back to Maya and then just like raise this like point up and then just re-import. That's all. Okay, so now let me then go to the other surfaces and repeat the same procedure, right? So this one is it's the next one. So Shift Y is to bring it back, and yeah. So cut, thicken again, right? So was it this one? Oh boy. Yeah, this one. Okay, thicken, and I'll be choosing this surface, and the remove this surface, and then merge scope is this top half. Okay, and then the thickness in here, I'll put it at, I think I'm gonna do like something like 0.01. Okay, so let's see, and then let's see, how does that look? Let's see, Y to make it. Yeah, so here this cut has been made in that thickness. Okay, so here in this case, this thickness is a little bit less than this one. It's I'm kind of like exaggerating it, but yeah. So, and then last but not least, do the same thing with this one. Okay, so yeah, so this one. Okay, so once again, cut, thicken, and oh, here it is. Face, and then remove, and merge with this body, right? And then point, I think it was 0.05, wasn't it? Okay. Oh no, was it 0.01? I think it was 0.01. Let me make this invisible first, and then go back to thicken, and then edit, and then just change it. Okay, 0.01. Yeah. Okay. Yeah. So, and cosmetic purposes, you know, you can give some fillets to these things. You know, Shift F is the fillet, which is also the same thing as this one. So let's see, let's do something like 0.01. That's, yeah, that's like the thickness of this. Actually, etch up thicken 1.01, 0.005. Would that be? Yeah, I think that's. Oh no, 0.01. Okay, okay, not bad. Can I include this one? Although it's in a separate. Yeah, so it's on a separate piece of volume, and it lets you do that. Solidworks doesn't let you do that. Solidworks, it'll say it has to be on the same volume, continuous volume piece. But OnShape lets you do it, which is actually I like it better. Okay, oops, I deselected this one by accident. So yeah, so this is purely cause a lot of times these don't really have fillets in the actual manufacturer. However, I'm just doing it for cosmetic and more like obvious illustration purposes. But that's kind of it, really. You know, let me just rename this. And what was this one? And then just let's see, mouse, organic, V2, and then I will call this a master model, because Solidworks call this master model approach, because master model is a part file that has all the the relevant parts pieces in a single part file, and then you would separate this into an assembly. So here the next step would be like naming these properly. So let's just name this. Let's do it quickly because I'm running out of time. Bottom, okay. Bottom, so I should say V2. Okay, so let's see. Let me just highlight this name and then just name this. So this is rename. Oh, come on, rename. There you go. V2. This is the top. So and then this one is the button. So V2. And I'm naming these because I'm going to create an assembly now. And then okay. Oh, I'm sorry, this is the right button. Yeah, so name them correctly. And I'm ready to create an assembly. So assembly is very easy. You just go down to plus and say create assembly. and new assembly file starts. And you have this empty space, and then you have to go up here now and say insert. Insert is and then it will browse through and then all the part studios and say, hey, I got all these part studios. What do you wanna? So you open this up, and there are these different pieces in this part studio. So it's just a matter of clicking one. Okay. Now, if you do move your mouse into the space, you have the option of placing this anywhere you want. But in this particular case, this is not really advisable, because if you place this arbitrarily in some space, how are you going to line this up to anything? Because this has no straight lines or flat faces or anything. So I don't recommend that. Just stay in here, like just choose this piece, and then continue doing that for the top, the button left. Oh, I'm sorry. Actually, you know what? I had mistakenly clicked, I think. So let me start over. So I was trying to just illustrate. So if you stay in here and say, I want the bottom, I want the top, and I want the button left, button right, they are like really well lined up at the origin, right? And just say click. And you don't have to do the extra work of lining them up. Isn't that nice? And what you want to do is you want to go here and do right mouse click and say fix, because that way you are guaranteeing that they're not going to be moved away from the origin by accident. Okay, so that's that. Okay, so this is the assembly, and then yeah, and then just rename that so that mouse organic V2, and then I'm going to say the whole set, you know. Okay, so that's the assembly. And if you want to create like an exploded view or something, this is the exploded view panel. And like just to illustrate like how it gets taken apart, this is pretty easy. I think that I may have to enable the movement here, but let me just try it anyways. You might not have to. So just say add exploded view. And let's see, can I take this? And oh yeah, I can take it apart. Okay, so there is that. Oh, I'm sorry, wrong direction. Let's see. I wanted to move it upwards. Yeah, actually, let me start over. Okay, so explode one. Yeah, I meant to click on this one. Okay, so and then you have the option of like specifying a distance, 1.5, and then yes, and then click another one and repeat for this button. Maybe for this button, I'll put it a little bit higher. Okay, whatever suits you, like visibly and clearly. And then enter to complete, and just click one more time to do oh, sorry. Click one more time here to do it for this button here. Okay, maybe, yeah, maybe I'll do it like that. So this one will be 2.5. And yeah, so that's the exploded view. Pretty easy to do. And then now if you simply just double click on this, it closes it. And if you double click on it, it opens it. Okay, so it's very easy. Double click, and that's it. So yeah, I think that's pretty much it for today. And now if you want to do further engineering on it, you would go back to this part studio, really, right? And then let's say if you do Y, and then hide it, and then say, hey, I want to do some like bosses and like holes or openings or ribs or whatever, then you would work with the planes here. This plane is like in the bottom, so it's not so useful. So just go to the plane here and then make a duplicate. Same as Solidworks, really. So offset, and then this offset amount, let's do it about here. Okay, yeah. So all right, so that's fine. So about a 1/4 inch or so, 0.25. Okay. Maybe a little bit higher, 0.35. Okay. So yeah, so you have this. So let me make this one invisible. Okay. And then let's see, Shift S for sketch, I think. And then let's go to the top view. And you can do like maybe you have a series of circles here, something like that. 1, 2, 3, and then you dimension it up and what into whatever. So 1.25 for this one, and for this one 1, and yeah, I'm kind of like just conceptually like thinking that this, and then and you want to define the distance from the origin, right? So I think, oh, I got out of dimensioning, right? So let's see. Yeah. Okay, there you go. Yeah, so you want to dimension from the origin. So like vertically, yeah. So this, and then 0.1, I guess, and then yeah. So that way you can constrain the position, and with this you can make holes or like structure or whatever, right? So you can, yeah. So I think that yeah, so you can start engineering this thing basically. So that's kind of it for the entire like thing, coming up with a organic form that is like directly sculpted, and then converting the geometry to the Nurbs state geometry that's usable by CAD software, and also creating the appropriate Nurbs surfaces that are important cutting part break surfaces, right? So this is like the beginning basis for product concept modeling, and then transitioning into CAD software.